Thank you, Joachim, and good morning to everyone. Welcome to Greenville, South Carolina. You're about 40 miles from our campus, which, do I have the clicker here? Oops. That's what it looks like on a foggy morning. It's surrounded by lakes you can see in the background. We have about 19,000 students on campus, and I want to give you an overview of our economic development approach and also talk about some of the new strategies that we're developing institutionally that we think will be very relevant to the private sector. As Joachim mentioned, my responsibilities lie on the economic development side of the university. There are 3 mission VPs at the institution, the provost, the research VP, and myself. And one of the things that we embarked on that we thought was really important over the past years, recognizing that the world economy as well as institutional economies, in that meaning state governments, were really impaired with the recent economic times, we decided that we'd use this opportunity to embark on a new plan for the institution. And that we needed it to be a bold plan, an aggressive plan, but it needed to be focused on a much longer range than the current economic climate we were dealing with. So the 3 of us went to every academic department in the institution, and we asked them before we went to help us address and focus resources on 3 global challenges. Challenges were health, transportation, and energy, obviously important no matter where you are in the globe. So we began the process of putting a 2020 plan together. And now to quickly give you to the outcomes of that almost year-long exercise from the beginning till the end, and the completion of the plan and the adoption by the board, we ended up with these 3 simple statements. And there's obviously layers and layers of paperwork and implementation strategies and budgeting behind those. But that our job was to help develop and provide talent, to drive innovation, and to serve the public good. We did not want to lose the idea that the altruistic idea of serving the public good. So within that strategy, the things that we decided to do were we were going to enhance our student quality as well as our faculty quality. We were going to attract, retain, and reward our top people, and we were going to aggressively build the kind of facilities for this 2020 plan that we felt like would make a strong economic development partnership with the private sector. For us, it was about how do you keep the very best and brightest? How do you keep kids that are the ones that are going to be the innovators, the entrepreneurs, the thinkers, and the leaders? How do you get new innovation to the marketplace? How do you go about securing and creating an innovation economy where people are always thinking? And we had done this, I think, at the graduate level, but we had really started now thinking about at the undergraduate level, how do you embed in the undergraduate students this entrepreneurial type of quality, the innovation type of characteristics? And then how would we go about building this workforce for the future? Just a quick slide, and this is not intended to be a bragging point, but we do have very bright students, and we've got 4,000 engineers with average SATs of 1271. So where are those people going to prosper? What are going to be the types of things in businesses that those kids become employees of? We decided that one of the critical things we needed, and as we deal a lot with the private sector. We have been, as a university, in business since 1889. We've actually been off campus with our economic development sites since 1901. Of course, those early sites were very much targeted toward agriculture and forestry, natural resource economic development. But the current stage, we decided that we were going to build, because the private sector insisted upon this, a strong workforce development plan. And I'd say equal in all the conversations we have. I think if you asked our team, what's the most important to the issue to the private sector relative to their work with universities? And we would say, based on the last 8 years or so of working heavily with engineering-related companies, that it would be an equal split between R&D and workforce development. The workforce development piece comes up in every conversation we have about partnerships. So we decided, too, to build a workforce development center. The National Science Foundation has come in and awarded resources for that workforce development center. The Department of Energy has as well. The center at ICAR, of course, focuses on systems engineering. We're focusing on energy systems engineering at the Charleston campus. This whole systems approach has been a key, I think, philosophical change for us as a university, is moving to a more holistic approach. When we talk to the private sector, that seems to be most of their interest as well. The idea that the universities must modernize and adjust their curriculum to the private sector's interest. And we have found that to be a very fruitful effort for us, both intellectually, but also in terms of relevance of our students to the marketplace. And I think MTI's Hawk talked with you all last night about the success of the automotive engineering program with 137 graduate students now after just 4 years of existence in automotive engineering systems. This is our state. Those of you that are not from the United States, this is the configuration of the state, with the right-hand side, of course, being the Atlantic Ocean, and the left-hand side being the Blue Ridge Mountains. These are the university's off-campus locations, physical locations. We have actually faculty at each of these locations. So it's not just a building or a field, it's actually physically faculty located off campus. And as I mentioned, we are used to doing this. We've been off campus for a long time. I want to take you through a few of these sites because there may be interest that you would have in actually working and collaborating with us as we work more and more with the private sector. We decided, and I'll take you first to our campus, that we had to do what we were going to talk about off campus. We needed to also embody the on-campus environment. So the president and I put together a white paper on the idea of building a net zero campus. Obviously, that's a marketing kind of term, but it is a philosophical change in the way the university started to do business. We had an aging infrastructure, electrical infrastructure, both in terms of energy generation all the way through energy distribution and then through energy consumption. Very aged system that we were going to spend millions of dollars replacing. And we decided to philosophically take a different approach to it, that we would engage the faculty, the students, and the private sector in creating this net zero campus, this new model for the campus. And so there are experiments going on throughout the campus with undergraduate students, with faculty doing sensor work across the campus in terms of energy consumption. And then we'll eventually get to the energy generation side, which has already started in some ways with renewable fuels. But this has been an invigorating kind of thing for the culture of the institution. It sets an aspirational goal that allows people to really start targeting their research around these areas. And we feel like it's been something that will create a new knowledge economy as well. You all will visit and spend time at ICAR. That's certainly our poster child when it comes to our work in energy systems and particularly automotive energy systems. We hired a new faculty member just recently in propulsion, Zoran Felipe. There are 4 endowed chairs at ICAR at this current time, with more expected. So it has attracted a wide interest from the private sector because the matching money for those endowed chairs does come from the private sector. ICAR offers a lot of full-scale testing, as well as very close work with the public and private sector intermingling on a regular basis. And I'm sure you have heard or will hear lots about Deep Orange. Deep Orange became a little bit, this is the idea of our students actually building a car as a part of their degree program, graduate degree program, and then adding new technology to that car as they move through the design process in collaboration with the Pasadena Art School. The idea of this building of a car as a component of your graduate degree has now been fueling the new thinking on the undergraduate side. It's how do you get your students more engaged? And right now we have about 500 teams of students that are planned for undergraduate, and that's teams, not 500 students, 500 teams of students, somewhere between 6 and 10 per team, that would be engaged in specific undergraduate research projects, multidisciplinary, multi-semester projects. And then we'll take a move to the other end of the state. This is where we are in Charleston, South Carolina. Just to go back and give you a feel, you see where Charleston is. Charleston, of course, has a port facility. The whole coast of South Carolina is a big tourism zone, but also enormous exports going through the port of Charleston. When the private consultants came in and looked at the East Coast, Ed McCallum said that the site that the Restoration Institute was on and the programmatic work being done there was the greatest economic development opportunity for our East Coast, which is really quite a challenge for us to deliver upon. And that challenge would be started with the delivering upon the largest renewable energy grant that has ever been released in this country for developing offshore wind. Of course, that is nothing new to Europe, but it is very new to the U.S. There are still no offshore wind installations for renewable energy in the United States, although there are meetings now going on in an RFP that just came out from the DOE to help partially subsidize some of the offshore ideas and begin the establishment of offshore wind farms, particularly in the northeast of this country. Give you a little bit better snapshot of the facility. That's the Charleston Peninsula. Of course, the bottom here is the historic district, the very well-known historic district. The rivers here are dotted with a variety of port terminals, and we are located right here at this physical location. This gives you a snapshot, actually, of the campus. Right here is the Clemson University campus, and with access to deep water, they're on dry dock number 3. That's the large shipping pier right next to us, and here's where our campus is located in Charleston. This is the front 27 acres on the campus, and these are the facilities being built. ICAR, we have now, between us and the private sector, about $250 million worth of investments there in the last 8 years, most of that in the last 4 years. At the Restoration Institute in Charleston, we will be somewhere around $170 million as soon as this first phase is finished. So you get a feel for the layout of the campus. The interesting thing about this site is because of that pier that you saw earlier, which is that little jut out into the river there, you have the capability of enormous handling of enormous specimens. So for engineers, it's the world's great playground. If you really want to handle large materials, 400, 500 ton types of fabricated units, you have that capacity at this site. We can move anything up to 500 tons directly into our testing facilities. This is where the facility where the grid simulator and the wind turbine test facility will be physically located. The Lash Laboratory is an advanced materials laboratory, and then a new graduate education center is going to be built here, similar to the one at ICAR. Just to give you a quick synopsis of what these energy systems approaches have yielded for us, our objective is to build with this drivetrain testing facility, and we really borrow from these campuses, so it's not, they don't duplicate, but they do borrow from each other. So Imtiaz Haq, who you met last night, is done a lot of drivetrain work in his historical career with the university, and of course at ICAR with the dynamometers there. But Imtiaz was also the PI on a project that landed another kind of drivetrain, a different kind of drivetrain for the next generation of wind turbines. And this gives us a chance then to really focus on the private sector and work with high value, high quality, cost competitive testing services, large scale testing services. And then there's always new ideas that come out, and these are not new or creative or something that nobody's ever thought of, but just the concept of what are we going to do in terms of other ways of lightweighting or creating energy efficiency. As long as we have the same structural integrity, could we not create lighter weight materials, and could different industry sectors not all benefit from that lightweighting component? So whether it's automotive or whether it's wind energy, or whether it's the defense-related types of applications like here, as long as you have good blast protection and you have lightweighting, it's beneficial and requires less fuel. Why work with universities? And to me, it's something that we apparently have not told our story as well, because when you talk to the private sector, there are lots of reasons that they have found universities to be challenging to work with. One has been the resistance to change, as you probably know. The fact that we were willing to make some adaptations in our curriculum to suit the industry, I think has at least opened a lot of doors for us in discussions. The idea of creating a workforce development plan that was not just about what is in it for the university, but a really K through 20 workforce development plan, working with the school systems all the way through a finished PhD product and thinking in that whole systems approach to STEM education and workforce development. And then these are just some of the more intrinsic things that if we start thinking of the laboratories as not ours, but shared laboratories, what do we have to offer to the private sector? We can provide a lower cost of doing work. We can leverage everyone's resources. We can share equipment. We can help accelerate movement to the marketplace. We can have people elbow to elbow with their future employees because our students are all participating now in all the testing that's going on. And then we have an opportunity for an exchange of knowledge among non-competing types of companies, which is a real advantage in sharing facilities. And then I'll just close with this example because all research, of course, does not take place in a laboratory. It takes place in many settings. And often the type of research that a person might be doing from one specific background has applications in other areas that would have never been thought of or intended. We had an ecologist and a computer scientist team up, and their concept was how do you manage nature? How do you develop a system that allows you, just like a vehicle is becoming more communicative with the driver, where there's a communication system being developed. It's not just I love my car, but my car and I have a dialogue. And how do we go about matching the car's abilities to the driver's weaknesses? So if a driver has certain deficiencies, can the car compensate? Can the car and the driver communicate in that way? Well, the same idea is here around nature. Can you communicate with nature in a way that you can manage that resource much more tightly? Think about, from an energy source, hydroelectric. So when we have hydro plants, just like any other kind of energy source, we collect certain data and we make decisions about a natural resource based on an energy consumption need. Well, by developing the right sensors and the right models, we have been able to now essentially set up a system that will allow us to have instantaneous management of an entire watershed. The National Science Foundation just provided $3.2 million to further support this work. But it would take an example of the Savannah River watershed and the many demands on that watershed from an energy standpoint, from hydro plants, from nuclear plants on that watershed, all the way to who wants to withdraw water for some manufacturing use or dispose water for some manufacturing use. Many, many demands on that resource. And lots of controversy right now on that particular river because of the need for it to be deepened, for the harbor to be deepened to handle the new 4A ships that'll be coming through the Panama Canal. So all kinds of controversy, high-level controversy with very little data to work from. And so our system then allows us to remotely, in milliseconds, be able to sense anything, anywhere on that river and determine that there's a pollution event right now at mile marker 37, not wait 3 days until there's a fish kill or 3 months until a water sample is tested and find out whether there was a pollution event somewhere on the river. So that kind of data and that kind of technology obviously has marketplace potential for this application. It also has just as relevant of application to be on a farm and reduce the pesticide use or the irrigation by having sensors born in the soil that are telling the irrigation or the spray rigs exactly what to do. It has the same potential application for factories that are painting vehicles or doing other things where you can manage all your emissions from a computer system and download all the data that would go directly into EPA or to your health and environmental control group in the state, and also has the potential of being embedded in a road system. So just that ability to think in multidisciplinary ways is certainly, I think, something that universities can do that would greatly help the private sector, and it helps us. I have always believed that every time we interact with the private sector, we become better faculty members, better teachers, certainly more understanding of their needs, more willing to negotiate on intellectual property. It's always interesting that universities get so caught up on intellectual property, and there aren't but about 15 universities in the country that really make any, I'll call, real money on intellectual property, but we spend sometimes forever killing deals because of our fear of losing something instead of finding a potential partner that would take that intellectual property and move it to the marketplace. And I know you have a break coming up, and I just again want to welcome you to our community and hope that you have a wonderful conference. Thank you.